You're welcome once again to New Focus Approach to Mathematics Basics 7. This is the revised edition, and in this video, we want to learn how to represent vectors from magnitude bearing form of magnitude and direction to component form. Okay, magnitude bearing form or magnitude and directional form to component form. We know that magnitude bearing form simply means having a vector like maybe 6 kilometers, maybe 30 degrees, and we want to write it in the form of, let's say, xy, whereby we have x component and y component. That is what we want to do for this very lesson. Now with this, we have our graph, so we are going to use graph for this one, and this is very practical lesson that you have to go through. So I'm going to do a demonstration, but then you can do the real work with your graph sheet. So get yourself a graph sheet. Okay, now what you want to do is that you want to represent this particular vector, which is 5 kilometers and then 60 degrees. We can measure 60 degrees with the protractor, but we can't measure 5 kilometers on the paper. So we can decide to say, okay, let's decide to say for every 1 kilometer, let's represent it by 1 centimeter, so that 5 kilometers gives us 5 centimeters. So we can use centimeter to do this, right? Good. So first thing you have to do is to locate the origin, because once we are talking about vector, it must start from somewhere to somewhere. So first of all, from our north pole, we are going to measure the direction, which is the bearing. Okay. So with our protractor, we position in such a way that our center will be at the origin, and then our zero mark will be on the y-axis, because you are going to read clockwise. Bearings are taken clockwise. So on the clockwise, we will measure up to 60 degrees. Then we draw a straight line from the origin to pass to the 60 degrees. Right. When we are done with that, we'll remove our protractor and then use our ruler to measure the distance from the origin to 5 centimeters. Whatever the 5 centimeters will be, then we make a mark over there. Then we trace the value from that mark to the x-axis and trace it to the y-axis. On the x-axis, we can see 5 here, and then on the y-axis, we can see 3 here, and that becomes the component. That means this one, okay, in terms of kilometer centimeter here, we can have the vector to be 5, 3. Now, do the practical aspect of this, and you realize that it is very, very easy for you to understand. Okay, now let's take another example and see. So this time around, we have 60 meters, 150 degrees, and we want to convert that to a form of xy, that is component form. So once again, from the origin, we position our protractor, and bearings is taken from the north pole once again, and it goes clockwise. So on the clockwise direction, we are going to read our 150 up to this point. Then we draw our line to pass through that. Again, we can't measure 60 meters on paper, so we can say, okay, let's have every 10 meters, let's represent it by 1 centimeter. So once we have 60 meters, we can call it 6 centimeters. So we are going to now convert 6 centimeters, 150 degrees to the component form, and let's see what will happen. So with your ruler, you measure from the origin up to 6 centimeters. So you have to do that with your measurement. Your value may not be the same as mine, because mine is not drawn to scale, but you can do yours to scale. In my case, if assuming that the 6 centimeters ends here, then I will track this value to the y-axis and track it to the x-axis. Coincidentally, our answer comes again as 3, -5. And so the value of this in the magnitude form, or the value of this to the component form, is 3, -5. So with this, I'm sure you can do more practical lessons as far as this part of the course is concerned. Go ahead and solve more questions. See you next time.